With RealFlow's relationship editor, you can define interactions between a scene's nodes, simply by drawing links between icons. This sounds very interesting, but the question is why this is necessary at all. Imagine a scene with several fluid emitters and force daemons. In this project, each emitter should be affected by a specific daemon. In an environment where all nodes interact without restrictions, this is simply not possible, because the forces act on the entirety of emitters. The only solution is to tell RealFlow which daemons and emitters are able to interact. And this is exactly what you can do with a relationship editor. The strength of this system lies in its flexibility, clear arrangement, and ease of use. A scene's nodes are represented as icons, and you can move them freely, create groups, add nodes, or change their attributes. You always have full control over each node, its simulation state, and connections. Let's take a closer look at the editor. The main element is a canvas. This is a place where new nodes appear and where the relations are created. With the help of an existing scene, we show you how to navigate through the canvas. To activate the editor's navigation, keep the Alt key pressed. Now, left-click and drag the mouse to pan. In order to zoom in and out, right-click and drag the mouse to the left and right. If your mouse is a middle wheel, it can be used for zooming too. When the graph is not completely visible, a navigator appears in the lower right corner. This box can be moved to reach the hidden parts of the graph. Another way to shift the canvas is to double-click on a free area. To select a node, simply click on it. A white circle indicates that the node is active. For multi-selections, shift-click on the nodes you want to add to the selection. Alternatively, it is also possible to draw a rectangle around the nodes. Active nodes can be moved to any other place on the canvas. Please note that you can not only select icons, but also the connections between them. If you want to select more than one connection, again shift-click on the links or draw a rectangle around them. Both nodes and connections are removed with the Delete or Backspace key. The Ctrl-Z shortcut will undo this action. When a node is deleted, it also disappears from the viewport and the Nodes panel. Generally, there is a close connection between RealFlow's relationship editor and the Nodes window. All node-related operations affect both windows simultaneously. For example, the creation of new nodes or groups, renaming, and the selection of nodes. Finally, there is the icon bar. It contains functions to accelerate your workflow, group nodes, rearrange them, and manage links. Most of the functions are self-explanatory when you apply them, but some of them will be explained in the following chapters. RealFlow provides various methods to create new nodes. They can be added from the Edit menu, the GUI's icon bar, or the right-click menus. Another way is the editor's tab menu. There, you also have a convenient search function. Just enter a few characters, and RealFlow lists the found node types immediately. Together with the first node of a scene, RealFlow creates a so-called system hub. A system hub can be seen as a global connector, where all nodes are linked to by default. Nodes, which are connected via hub, can interact with each other. If you want to change this behavior, open the tab menu again and deactivate Add to Default Hub. Now, the following nodes are created without a connection, and you have to draw the links manually. It is also possible to add custom hubs and create separate groups of interaction. The menu's remaining entries let you control a node's visibility, export resources, and simulation status. The latter is interesting, because it also affects the node's icon. In RealFlow, nodes can be active, inactive, or in cache mode. When it is active, the node contributes to simulation according to its relation with other elements of the scene. Inactive nodes behave as if they are not part of the scene, and in this case, the icon has a red label. The cache mode allows you to read already simulated data and use it for further interactions. The advantage is that you will not have to calculate the object's motion again and again in case of changes. Cached nodes wear a yellow label. All these operations also affect the nodes window, where you will also see your changes. Another feature that is available in both panels is the clone command. A node can be copied with the Ctrl-D shortcut. The special thing about this feature is that all properties and animation curves are duplicated as well. Group nodes are represented by a single node, and this is a very effective way to keep the canvas clear. If you want to take a look inside a group, just double-click on it. The contained nodes are displayed inside a light gray box that is attached to the appropriate group icon. The nodes can be repositioned and the bounding box is updated automatically. If you want to delete the group, but not its members, then click on the Explode Selected Groups icon. Individual nodes can be detached with ungrouped selected nodes. A special feature is nodes. These are a wonderful extension, in particular when you have to exchange a scene with somebody else. Nodes can be created from the canvas's right-click menu and resized to your needs. In order to enter some text, double-click on the node's upper part. A node is always located at the deepest level of the editor. This gives you the ability to group the graph visually. The node's own right-click menu provides some entries for changing the node's body and text colors. As previously mentioned, nodes are able to interact when they are connected. By default, new elements are added to the system hub, but this is not always wanted. In such a case, the links have to be created manually. When you link two elements, RealFlow checks whether this connection is valid or not. It makes, for example, no sense to link a gravity daemon with a camera node, or a standard particle emitter with a hybrid domain. When you create connections, forbidden nodes are dimmed, and the link cannot be established, but there is one exception. Nodes can always be connected via hub, and here, RealFlow checks internally if a connection is valid. In order to draw a new line, you can either click on an icon's colored circle and drag a line to another node, or Control-click and create the link. If you want to remove a link, click on it and press a Delete or Backspace key. Links via a hub are also called global links, because all nodes are able to interact. A direct connection between nodes is an exclusive link. Finally, there are implicit links. This type is not visible by default and only available for hub-based connections. Implicit links are the connections you have to create when the nodes are not linked via a hub. In the last chapter of this lesson, we want to show you a few typical examples for the relationship editor's mode of operation. The first scene contains each 3 gravity demons with different strength, cubes, and standard emitters. The task is to create 3 separate groups, each with 1 emitter, 1 demon, and 1 cube. One method is to group the nodes visually and establish connections between the individual nodes. In this case, it is not necessary to create a link between a demon and a cube object, because the cube acts as a static object, a container for the fluid. In scenes where the cubes are active rigid bodies, they also have to be linked with the demons. Alternatively, it is also possible to create 3 hubs and link the nodes via these connectors. In the next example, we have 15 active rigid bodies. 5 of them should be driven by a wind demon, 5 by an attractor, and 5 by gravity. Additionally, the members of each group should be able to interact with each other. Instead of creating a huge number of individual links between the nodes, there is a very fast and effective way. Add 3 hubs and create clusters of 5 elements with a group command. The groups and the appropriate demon are then connected to their hubs. And that's all. The task has been solved within a few seconds and just 6 connections. As a side effect, everything is clearly arranged and sorted. Now, we want to establish a setup for a simplified real-wave object splash scene. In a standard scene, an object that is linked to an object splash emitter hits a real-wave surface and creates particles. Both the particles and the objects are affected by a gravity demon. This configuration produces nice results, but takes its time. A very fast way is to decouple the splash emitter and the object. In the standard setup, all nodes are connected via a single hub, and now we delete it. All connections are removed, and the nodes can be reconnected as shown here. The splash emitter should only interact with the demons and the re-wave surface. The impact object reacts with the re-wave surface and the gravity demon. This is already the entire setup, and the modified scene is ready to simulate. This setup creates approximately 30% more particles, and the result is impressive as well. Force and K demons are often made exclusive. A nice example for working with demons is the creation of foam that vanishes after a certain time. The standard procedure for foam creation with standard emitters is the particle swapping method. In this example, a filter demon is used to define a threshold for the particle's pressure. If the pressure is higher than the threshold, the particles are considered foam and move to a container emitter. The container emitter is connected to a KH demon to define the foam particle's lifespan. Both source and target emitters are also affected by a gravity demon and should react with an object that catches the fluid. There is also a K-volume demon to delete escaping particles. Finally, the emitter should interact as well. A common question with RealFlow's relationship editor is how to keep the canvas clear. The second example, the node clusters, is already the answer to this question. Groups are a very effective method of arranging nodes and reducing the number of visible links. Hubs are another way to get clean graphs, because they can be used to create groups of interacting nodes. Colored nodes can also help you to create separated areas and classify the graph into functional groups. You should also consider using the editor's auto layout function. This handy tool allows you to arrange the nodes automatically in a very appealing way. Auto layout provides many settings to adjust this process, and the result is a clearly arranged graph. Last but not least, you should also consider the Show Connected Nodes function in the icon bar. This neat feature highlights all nodes which are connected to the currently selected node. For more experienced users, with the preference of the previous global and exclusive link system, we've added the spreadsheet table. Here you can monitor and create connections between nodes with just a few mouse clicks.